Yet, today, which topic you have covered?
So, I read all the topic little, sir.
Chemistry. Yeah,
No, sir, you can ask me the whole topic, sir.
yes, hold. Yes, good.
I will try to give answers, sir.
Yes, yes, good. And let me start first of all, basic introduce yourself.
Yes, sir. So, my name is Gaurav De. I am from Bankura, West Bengal, from where I completed my schooling. I pursued my BSc degree in chemistry from Bankura Christian College, and I completed my master's in chemistry from IIT Dhanbad. My hobbies include fitness and listening to podcasts about Indian Army and prominent personalities of India. Thank you.
Yes, good. Yes, first move on UPSC section. What is UPSC? What are the basic
Yes,
application
sir.
of UPSC? How do you feel about UPSC?
So UPSC is Union Public Service Commission. It is a central constitutional body. It established in 1928 and named as Federal Service Commission. On when Constitution of India come into effect, it named as Union Public Service Commission. It is under the Part 14 of our Constitution of India from Article 315 to 323. It has different functions like conducting exams of all India services, central services, Group A, Group B post. It frame and amend rules, provide advice to the president about promotions and UPSC annually annually provide a report to the President of India.
Yes, good. Next is why will you become a scientist B in UPSC? Why you want to join?
So it was my dream to work in GSI, and I come to know about GSI when I completed my masters. And from that day, it was my dream to join GSI and apply my knowledge to solve real life problems and do some field work. That's why I want to join GSI.
Yes, what the role of GSI scientist and chemist in UPSC?
So mainly as a chemist, our role in GSI mainly as an analyst. We do the analysis of different type of minerals, and we mainly check the water levels, water pollutions, and soil pollutions, and provide report to the agency so that they can take proper actions and do some proper actions to provide to stop the pollution, sir.
Yes, good. Next one is what are the basic difference ASI, GSI, and Central Groundwater Board? How it is work?
Yes, sir. GSI is Geological Survey of India. It is under the Ministry of Mines. It mainly deals with the earth geology in India, and it mainly do mineral resources, exploration of the mineral resources, and assessment of the groundwater and and environmental hazards, and where ASI is Archaeological Survey of India. It is under the Ministry of Culture, Government of India. It is a cultural and heritage site which which related with the archaeological sites and historical monuments of India. It mainly do the protection, exploration and excavation of archaeological sites and protects our historical monuments. The construction and mining operating in the near places of historical monument is controlled by ASI and Central Groundwater Board. As the name suggested, it mainly deals with the water problem and mainly deals with the water resources, water harvesting, and water problems, water pollutions associated in our environment.
Yes, you talk about the water. Yes, CGWB, center groundwater. Yes, what is water treatment?
Yes, sir. So, as we know that as the industrialization occurs, so our water becomes polluted due to the different type of industrial effluent mixed with water, as well as the acid mine drainages. So we mainly check the water pollution level, and there are different factors from which is considered for the to check the purity of water, like the pH of water, alkalinity, alkalinity, TDS, and dissolved oxygen, and the presence of heavy metal contamination, the presence of heavy metals. These are the water treatment, and we mainly for the heavy metal contamination we establish different plants, so that when the water drain from the industry, it gets purified, and there are certain systems developed where the wastage of water decreases. Sir.
Yes, how to remove hardness from water? What are the method and procedure from your side?
So yes, sir. As we know that there are two type of hardness present in water. Number one is temporary hardness, and number two is permanent hardness. Temporary hardness appear due to the presence of calcium bicarbonate and magnesium bicarbonate present in the solution, and permanent hardness appear due to the presence of calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate present in the solution. The procedure involved in the removal of the temporary hardness of water is just boiling the water, so that the bicarbonate converted into the carbonate and they get precipitated, and we filter the solution, filter the water. The second is the use of the Clark process, where we use the calcium hydroxide solution to precipitate the calcium bicarbonate, and in the to remove the permanent hardness of water. Number one, we use the washing soda. Number two, we use the Calgon process, and uh, number three we use the ion exchange chromatography to remove the hardness of water.
Yes. First is basic is which type of disease present in water?
Sorry, sir.
Which type of disease from water?
Uh, mm, Typhoid, cholera, and diarrhea. And due to the presence of heavy metals, there are different type of disease occur in our body. Like for the arsenic contamination, Blackfoot disease; for nitrate ion, blue baby syndrome; for the mercury, Minamata disease; for the cadmium, Ita disease, etc.
Yes. Next is distilled water and RO water. What the pH
Yes, sir.
between distilled water, drinking water, RO water, surface water, groundwater? First of all, what is pH?
pH is an unit is a system by which we check the alkalinity or acidity of water. In neutral pH, the pH of water is 7, and according to the Bureau of India Standard and World Health Organization, the drinkable water should have the pH between 6.5 to 8.5. So,
Yes. Good. Yeah, next move on your MSc project. Yes, what the basic application
yes, sir.
of your MSc project?
So I did my MSc project on excited state intramolecular proton transfer of green fluorescence chromophore. This is a special type of protein which emit yellow color due to its fluorescent intensity. So we can use this in gene therapy to identify the mobility of protein in the treatment of cancer, and as well as in environmental purposes. If we tag the GFP protein with E. coli, we can say the water pollution, we can locate the water control. Yes, sir. So should I explain it more?
Yes.
Yes, sir. If we tag our the protein of our interest with green fluorescence protein, so we can find out that in the cell where the protein goes, inside the cell where the protein goes, and in the gene therapy, if the gene of the green fluorescence protein is tagged with the gene of our interest, we can find out its activity in the cancer therapy. If we tag the tumor cells with green fluorescence protein, and if we employed some kind of drug which for the treatment of for the treatment of cancer, so from the activity of fluorescence, we can find out that will that medicine is suitable or effective for the for cancer for the to remove the growth of the tumor cell or to destroy the power of the tumor cell. At the same time, if we tag our green fluorescence protein with E. coli, we can find out the water contaminations.
Yes. What the beneficial point of from your MSc project in our society?
So, green fluorescence proteins, uh, since it is an act as a biological marker, so we can find out the activities of different proteins and different kind of drugs operate in particular type of cell, like in cancer cell. And by this help of this fluorescence technique, if we somehow convert this fluorescence into the phosphorus, so we can photosynthesize some reactions, and so that inside the cell we can produce the singlet oxygen, which is highly reactive, and it can destroy the particular type of cell in a small region. So this technique can also be useful to destroy the tumor cells or tumor cells, sir.
Yes. Any challenges, drawback, limitation of your MSc project?
So yes, sir, there are some challenges which I've faced. That if we extract the the nature green fluorescence protein, it lost its fluorescence activity, because in the protein, in the jellyfish where we extracted this from, where we extracted this green fluorescence protein, it is surrounded by the other proteins, glycine, serine, tyrosine. But when we extracted this protein, uh, its fluorescence efficiency decreases due to the photoisomerization. So our main challenge was to stop the photoisomerization and and at the same time we make it water soluble, so that we can use for the biological purposes. So we have to do many type of substitution in different positions, and we have to notice the different their activities and their solubility. So this was a time taking process, sir.
Yes. Next, move on the current affairs sections. Yes, have you studied current affair basic?
Yes.
AI, Chat GPT, DeepSeek, deepfake video.
No,
Yes.
sir. I no, sir.
Okay. Next one, GS section is geography, geology. First is geography. What the basic application
Yes,
of geography? How many
yes,
types
sir.
of geography?
Yes, sir. There are four types of geography: general geography, general geography, human geography, and physical geography, and practical geography. Practical geography, sir. From the knowledge of our geography, we can identify the climate change, and from the knowledge of the plate tectonics, we can find out the earthquake prone zones and different type of volcanic activities. And from the help of our this knowledge, we can find out the different type of rock systems and mineral extracted from them. And yes, sir. That's also.
Yes, geography is first basic is physical geography you talk about. What is physical geography?
Yes, sir. So in physical geography, we mainly deals with the we learn about the earth structures and different type of rock systems, the plate tectonic theories, volcanoes, mm, earthquake, volcanoes, etc. Sir.
Yes, soil. Yes, first is earth volcano. Can you describe what is earth and a volcano? What the effect of this one in earth?
So yes, sir. Yes, sir. The volcano is a opening vent or is an opening through which magma comes out to the earth's surface and becomes cool, and it is becomes cool, sir. So it is a volcano is an opening through which magma comes out to the surface, and when, as we know that the mantle consists of different minerals, and magma is a consist of the molten rock system, and these rocks contain different type of minerals. So this so the from the solidification of lava, when the lava gets solidified, we get different type of minerals, like like we get the basaltic rock, the granite rock, from which different type of minerals we get, sir.
Yeah, next, climate environment.
Yes, sir.
Yes, what is climate? What is environment?
Sorry, sir, I don't know, sir.
Yes. Next topic is analytical. We have discussed. I think is last day. We have discussed. Yeah, left.
Ye- Yes, sir.
Yes. Next, move on the technical part of chemistry. Chemistry is we have discussed in organic.
Yes, sir.
Yes, in organic we have discussed and left.
No, sir, not so much, sir.
Yes, organic chemistry. First is basic application.
The um, In organic chemistry, by the help of qualitative and quantitative estimations, we can find out the different type of elements present in the sample and different type of and their quantities as well. And by the help of the organic spectroscopy, we can find out the structures and number and type of protons and carbon present in the environment, sir. And by the help of this organic synthesis, we can develop different type of drugs, different type of compound, which will be beneficial to the humankind, sir.
Yes. Organic chemistry is GOC. What is GOC? What the
Yes,
basic
sir.
of GOC?
So in GOC, from GOC we mainly learn the nomenclature of different type of compounds, their and isomerism, structural isomerism, optical isomerism, and their nomenclature, the optical activity of a compound, whether it is optically active or not, and electrophile, nucleophile, different type of mechanism like substitution, elimination, addition, different type of intermediate like carbocation, carbonyl, carbene, free radical, nitrate, etc. sir.
Yes, first basic is resonance effect. Resonance effect, inductive effect, mesomery effect, hyperconjugation.
Yes, yes, sir. The inductive effect is a permanent effect which operates through the sigma bond, and it increases the stability of the carbocation as carbanion and carbon free radical as well. And resonance is a permanent effect which operates through the pi bonds, and it is a very effective. It is very effective to stabilize the carbocation, carbanion, and carbon free radicals, sir. And hyperconjugation is also an permanent effect, which also called the no bond resonance. It helps to stabilize the carbocation, carbanion, and free radicals, sir.
Yes. Yes, intermediate. What is intermediate? How many type of intermediate?
So intermediate is a substance or is a compound which produced in a particular type of in a particular reaction and decomposed or consumed in that reaction. In organic chemistry, we mainly found there are mainly found some kind of reactive intermediate like carbocation, carbanion, carbon-free radical, carbene, nitrene, benzene, etc. Sir.
Yes, carbocation, carboanion, nitrene, carbene, benzene. Can you describe?
Yes, sir. Um, mm, so how should I describe, sir?
Yes. Carbocation. What the hybridization of carbocation?
The carbocation is a carbon-containing species which carries the positive charge, and its hybridization is sp2, sir. And it is an electron deficient species.
Yes, basic idea only. Next is reaction mechanism. What is reaction mechanism? And how
Yes, sir.
of reaction mechanism organic chemistry?
The reaction mechanism is a hypothetical pathway which tells us the which tells us how the reaction goes from reactant to product. There are different type of reaction mechanism like addition, substitution reaction, elimination reaction, addition reactions. Substitution, addition, and elimination reactions are further classified. Substitution reactions are classified as an electrophilic substitution reaction, nucleophilic substitution reaction, and free radical substitution reaction. Addition reactions are further classified as electrophilic addition, nucleophilic addition, and free radical addition reaction. Elimination reactions are mainly three types: alpha elimination or 1-1 elimination, beta elimination or 1-2 elimination, and gamma elimination or 1-3 elimination. So,
Yes, nucleophilic substitution, elimination.
yes, sir, I told this. Sir.
Yes, first of all, elimination reaction. How many type of elimination?
So there are mainly three types of elimination reaction: 1-1 elimination, 1-2 elimination, and 1-3 elimination. So 1-2 eliminations are further classified as an E1 and E2, and there is also type of ECB. So.
Yes, basic idea of organic chemistry only. Yes, no.
Yes, sir.
Next one is pericyclic reaction, heterocyclic chemistry, aromaticity, stereochemistry. Yes. Can you describe it?
So I did not read about pericyclic heterocyclic chemistry. So
The next basic in chemistry is physical chemistry. Yes, what is physical chemistry?
yes, sir. So I don't know the definition, sir.
Yes, first physical chemistry is like chemical equilibrium. What is chemical equilibrium?
Um, so chemical equilibrium is a state in a reversible reaction where the rate of the forward reaction and rate of the backward reactions remain same. Chemical equilibrium are mainly of two types: static equilibrium and dynamic equilibrium. In equilibrium, both the forward and the backward rate constant remains same. So their concentration also remains same, but it is not necessary that both the concentration and the product have the same reactant, the same concentration. So their concentration can be same as well as different. So.
Yes. Next is electrochemistry. What is electrochemistry?
So in electrochemistry, we mainly deals with different type of cells and electrodes, sir.
Yes, what is electrode? What is cell?
So a cell is a combination of two different half cells, and each half cell consists of an electrode and electrolyte solution, sir, cathode and anode. And there can be a single electrolytic system, electrolyte, and there can be a different electrolytes, different electrolyte when the two electrodes present in the two different container. To connect them, we use the salt bridge, and the whole system is called the cell. And cell mainly of two types. It is cell mainly of two types: galvanic cell or voltaic cell, and electrolytic cell. In galvanic cell, the chemical reaction, the chemical energy is converted into the electrical energy, like Daniel cell. And in electrolytic cell, we use the electrical energy to the electrical energy converted into chemical energy. And yes, sir.
Yes, electrochemical series. What is electrochemical series?
So, elements are arranged in base of their reactivity or standard reduction potential from top to bottom or bottom to top, and this series and the series generated due to this arrangement of increasing or decreasing order of standard reduction potential is called the electrochemical series.
Yes. Electrochemical series, spectrochemical series, Irwin Williams series. Do you have any idea?
Yes, a spectrochemical series is a concept of coordination chemistry, and it is an experimental based series where different type of ligands and metal ions are. This series is prepared on the basis of different type of ligands and metal ions. In this series, ligands are arranged in increasing order of their field strength at the extreme left. As we move from left to right in a spectrochemical series, the ligand field strength increases. Initially, the weakest ligands are those which are both sigma tonal and pi tonal ligand, then sigma tonal ligand, then weak pi acceptor ligand, then strong pi acceptor ligand. Generally, halide ions are considered as the weakest ligand. And while the ligand containing the donor atom as carbon, like CO, Cn minus, are considered as the strongest pi acceptor ligand. So, and another, sir, Um, I did not recall the Ewing Williams series, as I know that it is a series which explains the thermodynamic stability of dipositive metal ions and dipositive metal ions, and the increasing stability is inversely proportional to their size. The stability, the order of this reaction is barium 2 plus strontium, and the increasing order of the stability: barium 2 plus, strontium 2 plus, calcium 2 plus, magnesium 2 plus, manganese 2 plus, iron 2 plus, nickel 2 plus, cobalt 2 plus, nickel 2 plus, copper 2 plus. But copper 2 plus, the stability of copper 2 plus is greater than zinc 2 plus. The additional stability associated with copper 2 plus is due to the Jahn-Teller distortion, sir, because it is a D9 system, and in octahedral environment, Eg orbital is unsymmetrically filled, so the splitting occur and the system achieve the extra stability, and it is considered as Jahn-Teller stability. So,
Yes. Next, chemical kinetic. Do you have any idea about chemical kinetics and thermodynamics?
yes, sir.
First is
Yes, sir.
chemical kinetic.
In chemical kinetics, yes, sir. In chemical kinetics, we mainly deals with the rate of a chemical reaction, and here we study mainly the reactions which occur at moderate speed, which does not deal with the reactions which occur at extremely slow speed, like rusting of iron, and we also do not deal with the reactions which are operate at very fast, like neutralization or precipitation reactions, and In thermodynamic, we mainly deals with the probability of a reaction or spontaneity of a reaction, sir.
Yes, chemical kinetics first is rate. What is rate? Rate of equation. Rate law.
Yes, sir. Rate law is an is the experimental expression where from where we can find out the rate of the reactions. How does the rate of the reaction depend on the concentration of the product, concentration of the reactant, sir? Yes, sir. Concentration of the reactant.
Yes. Next, order of reaction and molecularity. What the basic difference?
As we know that order molecularity is mainly deals with the order of a reaction. If we go to the definition, order is the in the experimental rate law, the sum of the power of the power of the concentration term of the reactant is called the order of a reaction, and molecularity is defined as the minimum number of reactant molecules are required to start a reaction. Molecularity is mainly associated with a elementary reaction, but order of a yes, sir. Molecularity is mainly deals with the sorry, sir. And order of a reaction can be zero, can be negative, can be fraction, but molecularity can never be zero, can never be zero, or can never be fraction. And in molecularity has no significance in a complex reaction, but in a but order. But for a complex reaction, we can evaluate the order of a reaction from the experimental rate law, sir.
Yes. Next is chemical kinetics. Basic is activation energy. What is activation energy?
The minimum energy required for the reactant molecule to convert it into the product is called the activation energy.
Yes. Arrhenius equation. What the basic relation between activation energy and Arrhenius?
Yes, sir. Rate constant equals to K equals to A into e to the power minus EA by RT, where K is the Arrhenius rate constant, A is the pre-exponential factor or frequency factor, and e to the power minus EA by RT, the whole term is called the fraction of molecules having having energy greater than that of the activation energy. A is called the activation energy, R is called the universal gas constant, and T is the temperature in Kelvin. So,
Yes. Next one is theories. Yes, no.
yes, sir.
Yes, conjugative reaction and parallel reaction in chemical kinetics. What the basic difference?
So parallel reaction in a reaction where the reactant converted into different product, one of the reactions occur at a high speed and another reaction occur in a relatively lower speed. Here we get mainly two or more than two product, and one of the product is major and the other product is minor. And in a consecutive reaction, the reaction occur in a number of steps where the reaction goes from reactant to product through a number of steps, and different type of intermediates are formed in these reactions, sir.
Yes, good. Next one is thermodynamics. What the basic application of thermodynamics?
Yes, sir. So, basic application of thermodynamics, sir.
Yes.
So, in from the thermodynamic, we can find out the efficiency of engine, efficiency of the engine, and the work done by the system or work done on the system, and we can find out the um, gives free energy, entropy of the system, sir.
Yes. First basic is thermodynamics is the system and surrounding. What is system? What is surrounding?
Yes, sir. The system is a macroscopic part of the universe which is chosen for the experiment, and the rest of the part is called the rest of the part of the universe is called surrounding. So system and surrounding both are both together creates universe.
Yeah, next is basic is thermodynamics is law of thermodynamics. Zero law, first law, second law, third law.
Yes, sir.
Yes.
Yes, sir.
What the main purpose of these law in thermodynamics?
So from the zeroth law, we get the idea of temperature. According to the zeroth law, if a body A and body B is in thermal equilibrium, and body B and body C both are in thermal equilibrium, then body A and body C both should be in thermal equilibrium. So from the zeroth law, we get the idea of temperature. According to the first law of thermodynamics, energy can neither be created nor be destroyed. It can be transformed from one form to another form. So from this statement, we get the idea that energy, this law states about the conservation of energy, and it tells us that should not be any perpetual motion of first kind, which can do work without consume any kind of energy, because work is another form of energy. And as we know that energy must be transformed, not created or destroyed. So there should be some amount of energy consumed to work for a machine. So it gets so the idea of perpetual motion of second kind, perpetual motion of first kind should completely rejected by this according to the first law of thermodynamics. According to the second law of thermodynamics, the second law of thermodynamics states that the net entropy of the universe is increasing, and in the third law of thermodynamics, we get the idea of residual entropy. So
Yes, what is entropy? What the basic difference? Entropy, residual entropy, absolute entropy.
the entropy is a property of a system which measures the randomness of a system, and a residual entropy is considered when the temperature is 0 Kelvin temperature. There are some compounds which, as we know, that the entropy randomness is generated due to the kinetic energy or the or the motion of the particles within a system. But at the temperature, at 0 Kelvin temperature, there is no kinetic energy of the molecule. So the molecule should be at rest. They should be motionless. But we see that there are some compound which shows entropy even at 0 Kelvin temperature. This entropy is called 0 Kelvin residual entropy, and this type of entropy arises due to the different arrangement of the particles in that system, sir.
Yes. Thermodynamics is what the basic difference, order of reaction and law of thermodynamics?
Order of reaction and
Law of thermodynamics. Basic.
sorry, sir, I don't know. I don't know, sir.
Next is basic in physical chemistry is colligative property. What is colligative property?
There are some certain properties of the solution which depend on the number of solute particle present in the system, and these properties does not depend on the nature of the solute particle. So these are considered as colligative properties. There are four colligative properties. Number one, relative lowering of vapor pressure. Number two, elevation of boiling point. Number three, depression of freezing point, and number four is osmotic pressure. And we see there are some abnormal colligative properties appear when the solute undergo association or dissociation in solution. So,
Yes, what is solution? How many type of solution?
solution is a homogeneous mixture of two or more component, and